starting with the great name of Almighty Allah, who is the most gracious and most beneficent. So the topic on which today I am going to demonstrate my presentation is on Penmen Monty equation. So starting with the evapotranspiration, I will just give a brief intro to it because there will be some factors and terms that will be used related to the evapotranspiration, because this equation is used for calculating or measuring the evapotranspiration. So let's begin with the evapotranspiration. So evapotranspiration is basically a process in which firstly a crop is when a crop or any soil in a crop and any plant surface is irrigated, then it gets some water, then the roots of the plants starts to get that water to the leaves, and then the transpiration takes place from the plant's body through the stomatas. So that's basically the transpiration. But when I talk about the any crop surface or any soil surface, when the water will be evaporated from the surface of the crop, that would be basically the soil evaporation. Means the water that converts into the water vapors and joins the atmosphere, that would be basically known as the soil evaporation. Combinedly, both will be called as the evapotranspiration. So what happens at the field, that these processes when these both occurs, it becomes difficult for us to distinguish between transpiration and evaporation. That's why we collectively call them as evapotranspiration, and its denotation is with the this ET. So there are some factors which affects the crop transpirations, and there are also some factors that affects the soil evaporation, but majorly it seems that both are affected by the same parameters. Like first parameters, I have mentioned some major headings of the factors that really that affects the crop transpiration and soil evaporation. First one is the weather parameter. Means if the weather is dry, weather is hot, then the evapotranspiration will be greater. And in second is the crop characteristics, with like which type of a crop is that, what is this developmental stage. Third is the management and environmental factors, that whether the land like soil fertility and soil water content, means whether the land is cultivated or uncultivated, whether it is there is any kind of crop or not, or whether it is barren land, and how much amount of water is present. If there will be a less amount of water present in the soil, then there will be less evapotranspiration. So coming towards the other word that here it is mentioned for the crop characteristic, that is the canopy cover. Canopy cover, if you have many of us have seen the trees. So the trees leaves form a kind of a umbrella shape. That's basically the canopy cover. Means whenever the canopy would be of the greater radius, what will happen, the soil beneath that will be covered by that canopy, by that leaves, because of which the evapotranspiration will become less. So these are the factors majorly affecting the evapotranspiration. So now for calculating the rate of the evapotranspiration, it is essential to know and measure these parameters. So now we will take these parameters and consider these parameters individually and independently. So here are the three denotations written in this column. First is the ET naught, second is the ETC, third is the ETC adjusted. So one by one, I will explain that why are these different and what's the reason behind them to categorize these. So what happened is that whenever we talk about the crop that process of the evaporation and transpiration. So when the weather parameters are considered, means weather parameters are considered and the crop would be of the any reference crop we will take. Like if I say that the Penmen used the reference crop that was the grass. Okay, so Penmen used the grass is the reference crop, and the standard conditions, that what are the standard non-limiting conditions? Standard non-limiting conditions are that there will be no water stress, no fertility stress, no water stress, no fertility stress, no disease, no pesticides. Means there will be nothing such condition that is going to affect the crop or going to create any of the resistance in the evapotranspiration. The only factor which will affect the evapotranspiration would be the weather parameter, and the reference crop will be taken. Usually they have taken the reference crop is the grass. So in that condition, the evapotranspiration would be known as reference evapotranspiration and would be denoted as ET naught. Means in this condition only weather parameter will be considered, and crop will be any reference crop, means that is the grass, and there will be standard non-limiting conditions. I think someone is opened the mic. Okay, another one parameter is here ETC. Means now earlier we were discussing a crop that was just a general condition was there, and only reference was given, that was only and only grass. But if we talk about any crop other than the grass, then for example any fruit crop is there, any vegetable crop is there, for example any tomato crop is there, then for that what would be the characteristics of that crop that will also affect the evapotranspiration, and weather parameters will also affect the evapotranspiration, then in that condition we call it as crop evapotranspiration under standard conditions. Under standard condition means that the management and environmental factors are not affecting it. Means, and those factors are like, means they will be well watered, means there will be no any water stress, it will be properly cultivated, means there will be no any fertility stress, there will be no any pesticides, means there will be no any disease to the plant. Means only two things will affect, and those two things are the weather parameters and the crop characteristics. In that case we say that the evapotranspiration is called as the crop evapotranspiration under standard conditions and denoted with the ETC. So now coming towards the third column, that is the ETC adjusted. Now in this condition, basically when we come to the field, we do not see that we always give the conducive environment according to our will, because there is a time when that is the we cannot control the um different like if there is not availability of water, then what there is likely chances that the plants are under it at water stress. So in that condition, that at field we cannot control so many things 100%ly. That is why we say that the evapor this term uh, got introduced, that is the crop evapotranspiration under non-standard conditions. Means the management, in this time management and environmental factors will also affect. Here is simple, just the differentiation between these parameters, that were between the reference evapotranspiration, crop transpiration, evapotranspiration under standard conditions, and in last the evapotranspiration under non-standard conditions. Means these all three parameters, all three factors will be affecting the evapotranspiration. So now we are moving further towards the Penman equation. For that, we will consider only evapotranspiration reference evapotranspiration, that was ET naught, and because it is just affected by the weather parameter, then we can also say that evapotranspiration, reference evapotranspiration is the climatic parameter, because it has only factor affecting is the weather parameter, and the reference crop is the grass with some specific characteristics: no water stress, no fertility stress, no temperature stress. These are the standard non-limiting conditions. So let's switching to the next slide. Penman equation. Initially, Penman was the scientist. He was physicist who gave the equation that was the Penman equation. Basically, his equation was containing some parameters that were unknown. What he did, he determined the vaporization and water removal in the atmosphere, and through his equation, but there were some variables in his equation, those were unknown, because of which that called as semi empirical equation. Penman used to firstly in the starting he used the reference surface is the open water, but later on it was changed to the grass. Penman was a scientist who just his equation was semi empirical equation, because still there were some parameters which were unknown. Further, Monteith, Monteith was a scientist who was basically the physiologist of crop physiologist. What he did, he brought and modified the changes in the Penman equation, so that the unknowns, those were unable that Penman was not completely was fully able to completely explain that equation or give the values of every variable. That was modified by the Monteith by what he did, he introduced some kinds of resistance offered by the crops, resistance offered by the air. So if you could see in this figure, there is a soil, and at this point the soil depth is there, height of this soil is there, and this is the crop height. Up to the crop height we call it is the evaporating surface, and these are the cuticulars, stomatal, that I will discuss, and above that line is the reference level, that is the height, because there is a certain limit at which we calculate the resistance above the air resistance above the plants. So for that there is a reference line. So what happens is that whenever we water the crop, whenever there is not water in the soil, means where less water is present, what will happen, that there will be a hindrance in the evapotranspiration. Why? Because there will be there will be no any water to evaporate. So that will be a kind of a resistance. The second resistance is the cuticular resistance. Basically, that cuticles are the plant layer covers are there on the cells of the plants, so that what the purpose that cuticles serves is that they protect the plants from the sun radiation, so that the water may not get evaporated and they may not get wilted quickly. For that, these cuticulars, that's what the purpose of the cuticular is. What happens is that if the it's clear that cuticular resistance is high. Why? Because if the cells are greatly covered with the thick layer of the cuticular, then the evapotranspiration will be affected. Second is the stomatal. Now there are some plants in which we observe that their pores are large. Some plants have pores large, and in some conditions they get opened largely, and some don't open at that much extent. So in that condition, if the pores will be large, then there are the great chances of the evapotranspiration. So if I talk about collectively the soil, cuticular and stomatal resistance that is occurring in the bulk, that would be called as the surface resistance and denoted by RS. And that would be known as the evaporating surface. Means this is the resistance combinedly the stomatal resistance, cuticle resistance, and the less, due to the less availability of the water in this soil, that hindrance will be collectively or in bulk will be called as surface resistance. Now coming towards the air resistance. If an area is there where the wind speed is high, or there is the highest wind speed, uh, high wind speeds, and that is flowing with the highest with a greater velocity, then what will happen? Then there will be a less evapotranspiration. This air will also cause the hindrance in it, and then the air will cause hindrance in it, and that hindrance is known as the aerodynamics resistance. So and it is denoted by Ra. Combinedly, if we put these both resistance in a series, means Rs and Ra, these will these will make up a line, and that whose height will be up to the reference line. Means there is a height up to which we will measure these two resistance constants. So coming towards the next slide. So this is the basically Penmen Monty equation that you can see. These terms I am going to explain you one by one in coming slides. But here a question rises that these three resistance terms, that is Ra, Rs and Ra. Sorry, these two resistance Ra and Rs. Basically what happens is that these two resistance requires when we measure these resistance, we require the expensive equipments. So not every department have the expensive equipment to utilize it and calculate and use and find those variables and apply this in this equation. Only the researchers are able to do so, because of which this becomes so expensive for us. So what happens is that what happened that the Food and Agriculture Organization made some little amendment into the Penman Monty equation, so that the Monty equation, because these resistance are difficult to find uh, with the with the for everyone, like where for those departments which have the expense issues are there and the equipment availability is not there. For that they changed the some condition, and those conditions are there. They consider some hypothetical grass surface. Means hypothetical grass surface under specific characteristics. Means they fixed the some characteristics of the crop of the grass, so that these constants can be easily calculated, and for that they just have calculated those constant and have make them fixed. So for if there will be a slight changes with the crop to crop or location to location, so they will just multiply some k factor to it and will use it. And what are those characteristic is that crop height would be 0.12 meter. Means crop height, whose crop height would be 0. That's basically the hypothetical grass surface whose height would be 0.12 meter. And the this is the solar radiation. This is explaining the whole phenomena that when the sun radiations will come to the surface of the crop, some of that radiation will joins in the grass crops, and that will what will crop do? Crop will utilize these sun radiations, and by utilizing it they will evaporate and transpire some water into the atmosphere, and means they are utilizing that radiations, and some of the radiation will be reflected back, and that reflected back radiation from that height of 0.12 meter crop is 23% and known as albedo. means albedo is the basically the percentage of the radiation reflected back by the crop surface. And now the surface resistance is the 70 seconds per meter, second. And now coming towards this RA. So these are the units that are fixed for it, in which they have measured 70. Another is the aerodynamics. Now this is the constant 208, but what is U2 here? U2 is the basically the wind speed in the wind speed at the height of the 2 meters. They have kept the reference line weather measurement up to the 2 meters. So that was means I told you earlier that there will be a specific height at which these constants will be kept in the series and will be calculated at the 2 meters. So these are the fixed values. Those are 208 point by, that's the ratio basically 208 by u2, which, and where u2 is the wind speed up to the 2 meter. 2 is indicating 2 meter at the height of the 2 meter. So that's basically the characteristics of the hypothetical grass surface. Now by inputting these meteorological data recorded in the weather stations, means at weather stations we are going to calculate these data, and when we will input these into the equation, this equation will somehow look like this. Means now there is no any such difficult factors which we cannot find. So moving further, so yes. Now here further in detail this equation is written and each term is explained. One thing I want to tell you here, that is this term, this factor, that this constant, that is 0.40408. What is it is that if we could see in this, that Rn is the calculated net radiation at the crop, which is measured in the, basically radiations are a kind of energy, so their units is the megajoules per meter square per day. Now coming towards the this formula, as you can see that the reference ET, that is the standard reference crop evapotranspiration, its unit is millimeter per day, but here it is the megajoule is their meter square per day. For converting this radiation unit, we are multiplying the 0.408 factor like this, that 1 megajoule per meter square per day is equals to the 0.408 millimeter per day, because this factor is Rn minus G is there, because of which we are multiplying this factor to convert that unit from megajoule per millimeter square to millimeter per day. Now let me now define these all terms which are written here, read for you. ET naught. ET naught is the standard reference crop evapotranspiration. For short trees, it is for short surface, it is then denoted by S, and then for tall surfaces there is denoted by S, and unit is millimeter per day for daily times steps, or millimeter per hour for hourly time steps. Second is the Rn, calculated net radiation at crop surface, megajoule per meter square per day for daily time steps for, or in terms of the hour for hourly time steps. G is the soil heat flux density at soil surface. So Rn is the basically that the radiation that is coming from the net radiation that is coming from the sun, but the this G is basically the, due to the radiation, some of the radiation will be absorbed by the crop. So that is what interlinked with this term G is that soil heat flux density at soil surface. That is also in terms of the radiation, megajoule per meter square per day for daily time steps, and megajoule per meter square per hour for hourly steps. T is the mean daily or hourly air temperature at 1.5 to 2.5 meter height. Now it is in centigrade, but if we see that T is in the formula T plus 273. Now T plus 273 is that because we want it in the Kelvin, because of it this factor is added here, that is 273 for the conversion of centigrade to the Kelvin. Now another term is the mean daily hourly wind speed at 2 meter height that I have already discussed. What is the U2? U2 here, and E is the saturation vapor pressure at this height, and whose use is kilopascal, calculated for the daily time space as the average of the saturation vapor pressure at maximum and minimum air temperatures. EA is the mean actual vapor pressure at 1.5 to 2.5 meter heights. These are specifying heights also. Another is the slope of the saturation various vapor pressure temperature curve, kilopascal per centigrade. That, and then there is a gamma, that is the sacrometric constant. Now the sacrometric constant is basically the ratio of the specific heat of the moist air moist air at constant pressure to latent heat of the vapors of the water. That's what the sacrometric constant is. And these all that parameters you are looking, there are also tables available from which we see that which for which crop how much radiation is absorbed for. So tables are available which can be used to input data into this formula. Another is CN 900 or numerator constant that changes with reference type and calculate time spent. Then the third is the and last is the CD 0.3 for a numerator denominator constant that changes with the reference type and calculation time.